My name is CJ Shan, and this is my colleague Varun Vasudev. And we are going to give you a talk about the best practice about Apache Hadoop YARN. So first, let's briefly introduce ourselves. I'm a software engineer from HortonWorks, and simultaneously, I'm the Apache Hadoop committer and Apache Sensor committer and a PPMC. Previously, I got the PhD degree from National University of Singapore, and my colleague Varun is also working for HortonWorks as a software engineer as well, and he is now the co-contributor in the Young community as well. Before he joined the HortonWorks, he was working for Yahoo to do the image and the web search. So today in our talk, we are going to share with you guys about some experience we have learned via developing the YARN platform and the applications on top of YARN. And our talk is going to be cover the following two parts. The first is best for the administrators, the people who are going to operate a YARN cluster. We are going to give you some hints and tips to tell you how to operate your YARN cluster efficiently. In the second half, we are going to cover some interesting things for the YARN application developers to give you a checklist to make sure you are developing your YARN application properly. So the first half, I would like to introduce my colleague of the room to brief you guys.
Thanks, Shizi. So I'll mainly be talking about best practices for administrators of a YARN cluster. This is just stuff we've seen from our interaction with customers on best practices. So I'll basically be covering the YARN configuration, some stuff for resource manager, go over the schedulers, the node managers, and the other stuff is log aggregation metrics, again, stuff that we feel administrators of clusters you find useful. Just a quick overview of the YARN configuration. So almost everything YARN related goes into a file called yarn-site.xml. The individual config variables are fairly granular, but they're well documented. You can go on the Apache website and find a lot of useful information there. Nearly 150 configuration variables are in that file. Some of them are required. These are things like a resource manager host name, node managers, host names, and stuff like that. Some is common, like client and server config. Some are advanced configs, such as RPC retry policies and stuff like that. In general, if it has yarn.resourcemanager.star and yarn.nomad.star, these are usually meant to be server-side configs, not to be looked at by clients. Admins can mark them as final, which is essentially a hint to a client saying, don't really mess with this, don't override it. Yarn.client.star is client-side configs meant for client submitting apps. Everything YARN related is security, resource manager, node manager, timeline server, a lot of scheduler stuff all goes into this one file. There's also a topology script that you can put, you can enable, which tells all nodes the network topology in terms of rack information, which is useful. That also is hooked up into this config file. So resource manager. For those of you who are coming from the Hadoop 1 world, resource manager needs CPU, but it doesn't require as much memory as a job tracker. Typically, 4 to 8 GB of memory should be enough. However, if you're running a job history server for MapReduce, that still is a memory-intensive thing, so it needs at least 8 GB of RAM. RMHA. RMHA is a relatively new feature. There was a talk yesterday by Shwan and Karthik about it. We highly recommend you enable it. Overall availability of the RM improves tremendously. It's only supported using Zookeeper, so you must set up a Zookeeper cluster. We use Zookeeper for the lead direction as well as for fencing support to control writes for common store. Automatic failure is enabled by default. It uses Zookeeper for that. There's embedded ZKFC, so unlike I think the name node, you don't need to start a separate process to take care of this. It'll just take care of it automatically. You can again start more than 2, 3. You can start 2, 3 resource managers. It's not a problem. The way you do this is you specify RM IDs using the config variable shown, the YARN resource manager HARM IDs. You can specify in the config file how many RMs you'd like to run. And then you have to associate host names with those RM IDs. The thing to be aware of here is that you don't need to change any other configs. Scheduler, resource tracker address is automatically updated. In addition, the web UI will automatically redirect you to the active RM. You don't have to worry about trying to find out who the active RM is. It just sends you there automatically. Moving on to the schedulers. So two main schedulers. There's the capacity scheduler and the fare scheduler, the most common out there. Capacity scheduler is really meant for large multi-tenant organizations, helps you split up resources and guarantee resources. The fare scheduler is a fair distribution of resources across applications. Both have admin files that can be used to dynamically change setup. So while the cluster is up and running, you can change things. And if you have HA enabled, please be aware that the queue configuration files are stored on local disk. So if you have an active, if you have a standby RM which becomes active and the queue configuration file differs, it will use the one on its disk. So you should make sure that the queue configuration files that you use for your schedulers are in sync. Or there's a feature coming to centralize the queue configs. If you don't mind waiting for that, then that is another option. So this is just a quick split, diagram for the capacity scheduler. Essentially, is just, as you can see, there are multiple queues. Each one has dedicated resources. So queues are hierarchical. There's a requirement that capacity must add up to 100% at each level of the hierarchy. The useful thing here is essentially you get to guarantee a certain number of resources. This is useful if you're a large organization with many business units. Each one wants to contribute a certain number of nodes, but be guaranteed that they want those nodes when jobs from that org are submitted and stuff like that. Queues, there's a support for elasticity, so if the cluster is not being used, queues can expand what they're using. So the main config file for the capacity scheduler is called capacity scheduler.xml. Please take some time to set up your queues. If you get your queues right, it makes things a lot easier. We find a lot of people don't spend enough time in figuring out how to set up their queues, and then when there's competition for resources, you end up suffering. Queues also have per queue ACLs, which is really useful. This is really useful if you have queues. For example, you're running tests and production on the same cluster. You can restrict who submits apps to which queue using these ACLs, and these can be dynamically changed using the queue files. In addition, elasticity can be limited. You might have a queue that has 30% of the cluster, but under no circumstances do you want it to, say, take more than 50% of the cluster. There's a variable called yarn scheduler capacity, and depending on the queue path, you can limit its maximum capacity. The other really useful feature is you can drain a queue at runtime. If you find queues are essentially overwhelming a cluster, what you can do is use that variable listed there, the yarn scheduler capacity queue path state, set it to stop, dynamically refresh using the yarn RM admin command, and that queue will essentially stop submitting new apps in the cluster. So you essentially end up decommissioning a queue. You can get your cluster throughput or latency back to a level you find acceptable, and then recommission the queue by again setting that state to a running state. The fare scheduler is slightly different in that it was designed to give apps an equal share of resources on average over time. One of the good things about the fare scheduler is you don't need to worry about starvation, which is actually a real potential problem with the capacity scheduler. There's support for queues, but really queues are meant for a way for someone to prevent them from flooding the cluster with a lot of apps. It also has a fairness policy which can be changed dynamically, and it is really useful as a really good scheduler if you have lots of small jobs which tend to finish fast. So one of the things we highly recommend is, I think, just sizing containers. There are 4 variables that are of the format yarn scheduler dot star hyphen allocation hyphen star. They control how much memory and CPU by the minimum and maximum memory and CPU a container can obtain. Now the defaults are 1 GB, 8 GB, 1 core, and 32 cores. Now the thing there is the node manager today actually only enforces memory limits. So you might, on a 64, if you can see in the graph on the right there, you have a 64 GB node. It can potentially be running 64 containers simultaneously. Now, if you don't have enough, if the containers are, say, mainly CPU bound, what will end up happening is they'll all be competing for a small number of CPUs scheduled on the same node. So what we recommend is instead that you map most of your resource requirements into a memory requirement. That way you can guarantee that at least on node, you are not competing for similar resources. Especially if you have, say, extremely CPU intensive or disk intensive apps. Just as a way of blocking out, just map all those requirements to a memory requirement, and then when you're submitting the app, try to claim that much memory and try to get as much of the node as you can. For node managers, there is, again, a variable called NodeManager resource.memory.mb. This sets how much memory Yarn can use for containers. The default, again, is 8 GB. It might not be appropriate for your cluster. Just the only thing you should be aware of there is don't set it too high because that can lead to thrashing across on the node. We highly recommend setting up a health checker script. Yarn today has a communication resource manager to determine health of a node, but it doesn't do too much health checking. So for example, an app can fill up a disk on node manager, on a node. The node manager won't detect the full disk, and what will happen is that new apps submitted will keep failing because the disks are full. A health checker script can do stuff like figure out if a disk is 90% full, start marking the node as bad, and then automatically resource manager will stop submitting new tasks to that node. In addition, sometimes we find apps require access to external networks for getting some resources they need for completion, and some due to misconfigured firewalls or stuff like that, something goes wrong. These scripts are really useful for weeding out bad nodes so that they don't end up with failed tasks. There is a physical and virtual memory monitor that runs on every node. By default, it checks the physical and virtual memory that a task is using. Now, the way it does that is it looks at the amount of memory a node, the task has been allocated, and the physical memory limit is the memory it was allocated. The virtual memory limit is 2.1 times the physical memory limit. A lot of people find this ratio to be way too low, that containers need to get more virtual memory, and so that default ratio of 2.1 might be too low. The final point I'd just like to raise is typically nodes have multiple disks, and HDFS is running on those nodes. We haven't seen this in the wild yet, but potentially HDFS access can affect your disk performance. So you might, if it becomes really bad, want to think about dedicating a couple of disks for Yarn and the rest for HDFS so that you have a separation of concerns there. Log aggregation. Log aggregation, I think, is the simplest no-brainer decision. Everyone should turn it on. It requires a fairly simple setup. All you have to do is turn it on and tell Yarn where on HDFS to put the files. You can control how long you keep logs, and you can get logs for any app using the yarn log command. It makes debugging and figuring out why apps failed tremendously easy. The only drawback is that you might end up creating a lot of small files and affect HDFS performance, but that can be cleaned up using the purging parameter. Metrics. These are just you find some useful URLs that people tend not to know about. There's, on the resource manager HTTP interface, if you use /JMX, you get a whole bunch of JMX metrics in JSON format. You have a lot of cluster metrics available, such as the apps running. You also have queue metrics for the scheduler, and this is for every queue in the hierarchy, so it's not at a top level or something. You get very, very detailed queue information out there. You also get metrics on the RPC performance, apps submitted and the security stuff. The web UI has a lot of similar information, but the scheduler metrics for the queues are a bit easier to digest because they're essentially visually much more informative. They have color-coded stuff on how much queue capacity is being used and things like that. And the metrics can directly be emitted to Ganglia if you have the metrics configuration file set up correctly. And that's it on my end, so I'll hand back to Shizi for the application developers.
Okay, thanks, Varun, for giving us a nice briefing. So in the following part, I'm going on to introduce something that might interest the people who are developing the Yarn applications. So for those who want to develop Yarn applications, the first things you would like to think is not how to write the application. The first thing you would like to think is whether you are going to take advantage of the existing frameworks or you want to implement your application completely on your own. Actually, the situations in the current Apache Foundation is that we have already a lot of existing frameworks you can take advantage of. This application frameworks includes the MapReduce that can help you to do the batch processing, and we have the Storm and the Sensor, which can help you to do the streaming data processing. And if you want to do the interactive job processing and the iterations, you may want to choose Apache Test and Spark. If you would like to have something similar to SQL, you may want to choose Hive. And you can also use Pig for the data pipeline and use Giraffe for graph processing. And last but not least, it's sliders. It is actually a new thing to the Apache Foundation, but it is really cool stuff on top of Yarn. It can bring your existing application on top of the Yarn platform without any code change. So when you want to move your business on top of Yarn, you can think about these tools to see whether these tools fit for your business. So the next thing is that if anyway you find your business logic is so unique that you want to completely write it on your own, you still have some other choices. The slider is the one I have already mentioned. With the slider, what you can choose to do is to write your own application as you did before and deploy it via the slider to the Yarn platform. But if you don't want to do that, you want to really have some Yarn fashion, you may choose to use Twill and Reef. These are some SDK tools on top of Yarn that, for example, Twill can help you to write a Yarn application just like the multi-threaded Java application. But anyway, if you find that these tools is still too constrained for your business logic, you want to have full control on the Yarn stuff. For example, you want to decide when you allocate a containers, when you want to start containers, stop containers, then you can think about to write your Yarn application on your own. But don't be afraid of writing your Yarn applications. We have already provided you a lot of good stuff to help you to write a good Yarn application. So the first thing I would like to mention at the beginning is to understand the Yarn component first. I guess most people here should have the concept about that. So I would like to spend too much time here. So the Yarn, in a Yarn cluster, it has two stuff. One is a resource manager. It is master to control everything in a cluster, and it is also going to be the main point for your application to contact. The NodeManager is a manager of a single machine. It is going to control the resource on that machine, and it is also responsible for running your business, your application code on that machine. So application master, for this name, you can know it is going to manage your application. In this cluster, it will be used to contact the resource manager to negotiate resource for your application. And the container is the thing we can think in two ways. In one way, we can think about it's a collection of resources, such as memory, CPU, and a disk. On the other side, we can take it as a process that is executing your business logic. So for a young application developers, actually you are responsible for two things. The first one is a client. This piece is a bit small. In this piece, the main things you want to do is to maintain the contact between client and the resource manager. You need to submit your application to a Yarn cluster. The other piece is relatively bigger. It's an application master. In the application master, of course, you need to manage your specific business logic. But in addition to that, your application master is supposed to contact the resource manager scheduler to get your resource you want. And you also need to contact the node manager to start your work there. So before we talk about the details about the client and application master, I would like to mention the rule of thumb here. So please make sure you are always want to use our client libraries. Yarn has already provided a number of good libraries for you to use. You should use it instead of sending the request to the protocol interface directly. These libraries can significantly reduce the work you need to do. There are 4 pieces for major client. The Yarn client is going to be used on the client side. You are going to use it to submit your application. You can also use it to kill the application and get the application information, get the class information, a lot of stuff. And the AMRM client and the NM client are supposed to be used in application master. We have provided the synchronous version and asynchronous version of these two clients. The reason why we would like to do why we would like to have the asynchronous client is that in many cases the young components is handling the request in a synchronous way. Which means if you send a request to a young component, it's not going to respond to you immediately. Instead, you need to query your response at a regular interview and to see whether your response is ready. So the asynchronous client is helping you to get rid of this logic. What you need to do is to just compose some logic to handle the response and put it into a callback function. You can provide this callback function to the asynchronous client, and the client is going to help you to check when the response is ready. When it finds the response is ready, it will invoke your callback function and to process the response. So the last but not least one is a timeline client. It's a really new piece because we have just bring the timeline server into YARM in 2.4. I would like to cover these things a bit later. So then let's look into the ways we want to write a young client. So please make sure when you write a young client, you are going to make the following 3 steps in your code. The first thing is to get an application ID from Resource Manager. The second piece is actually large. You are supposed to put everything that is necessary for your application into a bundle, which is an application submission context. And the last step is just to put the bundle to the resource manager. So in the bundles, you would like to make sure you put for example, the share command to start your application master. You want to make sure you have put the environment variables and some local resources, such as the Java libraries your application will need. Here are some tips for writing a client. The first thing is that when you implement your client, please make sure you have 0 assumption on the cluster, which means you may not know the class location, you may not know the class size. So your application is going to be run locally or run remotely. Your application is going to be run on a 10 nodes cluster. It is going to be run on a 1,000 nodes cluster. So please make sure when you implement your application, your code is so general that you are not specific for a typical type of cluster. And the second thing I would like to mention here is that the young class may not have installed the libraries that you want to use for your application. So when you submit your applications, please make sure you have added all the library dependency into the application submission context and put it and submit it to the resource manager. Then let's look at the application master. So for the application masters, at the beginning and at the end, you are always doing the registration and unregistration. That 2 step has defined the active period of your application. Only during this period, your application master can do the heartbeat with the resource manager and send the container request to the resource manager via the heartbeat. And when you get the allocated containers, you can compose a container launch context to include some environment some commands and also the Java libraries. This here it is pretty much like you submit a application, but here you are just submit something to do part of your work. So you have a bundle everything together into a container launch context and push it to the node managers. The node manager will be responsible for you to start your work. Here is some tips for writing an application master. First of all, I would like to say, as I mentioned before, the Yarn component is going to handle things in a synchronous way. For the container allocation, it is the same here. So when you request a container, you may not get the container immediately. What you need to do is to keep doing a heartbeat and send the empty container request, and you are going to get your allocated container in the follow-up heartbeat response. Please make sure you are not going to send the container request duplicately here. Otherwise, you are going to be allocated more containers than you requested. The second thing is that when there's a resource available in a Yarn cluster, the resource manager can guarantee it will return you a container. But the thing is that the container may not be allocated on the host you want. So, for example, you may want to get a container on host 1 for the locality, but actually you can only get the container on host 2. Make sure in your application master you are going to handle such kind of situations. For some reasons, you may want to relax your container locality. And the third thing is AMs can fail. This is because it's a distributed system. The cluster can fail here and there. Your application master may be failed for some reasons. But the good thing is that Yarn has provided you the mechanism. It can help you to restart your application master when it fails for some reasons. But one thing you can do here is to implement your own recovery mechanism within your application master. For example, you can have the checkpoint. With this mechanism, when your application master gets restarted, you don't need to redo all the work from the very beginning. Instead, you can just continue your work from the last checkpoint before the failure. The last thing here I would like to mention is that Yarn is not going to responsible for the contact containers for you. Your application master need to start the containers to launch your work and to stop the containers when the work is done. Also, you want to get the container status to watch whether your work is still working well. So the next part is about the timeline service. As I just mentioned before, this part is newly bring to the Yarn from 2.4. The reason why we would like to have the timeline service is because we would like the applications to record down their important metrics and metadata, such that the clients, the users can come back later to check whether to analyze it to see whether the application is running well on the Yarn platform. For the developers, it is quite simple to do that. You can just think about what is the important metrics for your application and put it into some Postgre objects and send it down via the Yarn client, timeline client. As we have introduced the client and the application master, then let's go through the typical workflow of a Yarn application. So first of all, the client is going to submit an application to resource manager. When the resource manager got the application, it will get a container to launch the application master process. When the application master has been started, it is going to do the registration with the resource manager. And after that, according to your business logic, your application master can ask a number of containers from resource manager. and then put some specific logics into the containers and send it to the corresponding node manager to start the work. Meanwhile, while your application is running, your client can always contact the resource manager and the application master to get the up-to-date information. For example, how much progress has your application already achieved. And the final thing for the application master is to do the unregistration. In your application master, you need to have some logic to determine whether your application has completed all the work. When it is completed, you should contact the resource manager to do the unregistration. Then your application master is safe to exit. Okay, at the last, we would like to share you some lessons we have learned before. The first of all is please take what Yarn has offered to you. So Yarn is a resource management system, but it is not just do the resource negotiation for you. You can make use of Yarn to do more things. For example, you can make use of it to monitor your applications via different channels, via different interfaces. In addition to that, Yarn still have a lot of features, such as high availability. So when you are writing a Yarn applications, you would like to check the latest version of Yarn to see whether there are some new features you want to make use of. The last but not least is debugging and testing. So when you're writing your applications, you will always have some problems. So we have a number of tools to helping you. The first is a mini Yarn cluster. It is in JVM Yarn cluster. You can write your test case on top of it. You can, and so such that you can do the regression test for your applications. Another fantastic stuff is a managed application master. This is an application master that is running out of the Yarn cluster. It can run on your local machine. That is significantly simplify the way you debug the issues in your application master. And a good thing I would like to mention here is that when you are running an unmanaged application master, the logs of the application master is going to show on your console directly. That would be pretty simple for you to find some problems. And finally, your application is going to be in production and running on a Yarn cluster. So for some reasons, your application got crashes, has some problems. There are two places you would like to check. The first is the resource manager and the node manager logs. These logs can help you to find out whether your application has something wrong to deal with the Yarn cluster. And the other thing is application aggregated logs. From these logs, you are going to find out some internal issues with your application. Okay, that is pretty much from our talk. So we still have a couple of minutes. Any questions?
Yeah. Please use the mics so they can record.
Oh.
Mic is there.
So my question is, so all the heartbeat messages between the node manager and the resource manager, so how do you define the granularity? And can you define the granularity in the yarn site.xml or somewhere else?
Yeah, I think the default is, I think it's a 3-second heartbeat from the node manager to the resource manager. And I think it can be changed, but you should just be careful, because if you don't want too many heartbeats, it just ends up draining resources on the resource manager.
Correct. So if I increase from 3 to, let's say, 5 seconds or something,
well, then that's the other
does it impact?
I don't think it impacts it too much. I think it's just a question of what you feel is right for your cluster in terms of are you okay with the node manager, the resource manager taking 5 seconds to realize the node is bad. That's essentially it. I don't think it has any impact on performance. It might have an impact on overall throughput, because we're taking longer to figure out a node has gone down. And so we're still trying to allocate tasks to a node or waiting for its response.
So the change goes into a on-site XML?
Yeah.
So last question is that you mentioned that the client has to send a lot of empty requests to get the containers.
Yeah.
It's not guaranteed to get them in the first shot.
Yeah.
So those requests, they get translated from node manager back to the resource manager asking for the containers?
No. This is from the application master, so it is.
Sorry, application master,
yeah.
I meant. Yeah, sorry. Yeah, so let's say if a client asks application master, it sends the empty container request. Does it go via application master back to resource manager?
Actually, the thing you want to do is because you want to, the heartbeat is always there. You need to maintain the heartbeat with your resource manager to at least to let your resource manager know your application is running. So via the heartbeat, you can send the container request to ask for example, you want to ask one container, and in the following heartbeat, you want to keep the request empty because you don't, let's say for your logic, you don't want to request any more containers. So you just need to send the empty request there. And, but once you send a heartbeat to the resource manager, you will get heartbeat response. So in some of the follow-up heartbeat response, you are going to get your allocated containers.
Got it. Thanks. Appreciate it.
One of the suggestions that you said was to have different disk volumes for SDFS and separate disk volume for yarn.
This is we haven't seen a use case for it yet, but it might be potentially something users might hit. It's just something to be aware of.
What kind of conflicts that do you expect?
Oh, nothing. It's just that if you have a lot of an app, for example, that's running a lot of logs to disk, and you have a lot of HDFS data node activity on the same disk, so you might just be conflicting. But we haven't actually seen that. It's just something you guys can keep in mind if you find that disks are getting overloaded in terms of operations per second.
My question is on the property and the command that you shared on the capacity scheduler.
Yeah.
So there's a property to drain the queue, right?
Yeah.
The property is capacity dot some state.
Yeah.
Is it only for capacity scheduler?
Yes, it's only for capacity.
So there's nothing for phase share?
No, not that I know of. I don't believe there is one.
But I guess the command for refreshing queues is same for both?
Yes, refresh.
Okay, thanks.
Hi. Do you keep virtual memory limit enabled for your task?
Sorry?
For a container, you can specify virtual memory limit.
Yeah.
And do you keep it enabled? And if yes, what ratio do you use comparing to physical memory?
Wait, I'm sorry. Can we just talk after? I didn't quite get your question right.
So you have two limits for
physical and virtual, yes.
Yes, and do you monitor?
Yes, by default, both are turned on. But we have seen a lot of cases where the virtual memory limit doesn't make sense for most people, and either they turn it off or they just increase that ratio to a really high number so they know they won't hit it. I think whether you choose to turn it off or you increase the ratio is really what your preference is. I think it makes sense because at the end of the day, you don't want somebody going crazy on a node. But I think 2.1 might be too low for a lot of people. Okay. I would increase the ratio in most cases.
The capacity scheduler in 2.1, you have preemption available, right?
Yeah.
So with that, I did not understand how starvation is possible in capacity scheduler.
Preemption is enabled, but I think we have seen cases where the feature doesn't work very well. It doesn't work correctly. So I think it requires a bit of stabilization. But yes, once preemption is there, then starvation should go away. Okay. But right now, I think we have seen cases where it doesn't work very well.
Is this something you're targeting for 2.2?
Yes.
Okay, thanks.
Hi. Can you switch back to the last slide?
Okay.
One more. Sorry, the number 7 in the schedule. Yeah.
Okay.
So number 7, a client talking to AM directly, right? Is there a published protocol?
Oh, yeah. Actually, I would like to explain more things here. If you want to make sure your client can talk to your application master, you need to be responsible for implementing this kind of protocols. you need to define the protocol between your client and the application master. Otherwise, we only provide, the Yarn only provided the protocols between the for the communication between the client and the resource manager.
Right, yeah. Okay, so the client needs to have its own protocol in order to talk to the AM.
Yeah.
Yarn doesn't support.
Yeah, Yarn doesn't support that right now.
Okay, thanks.